since for the most part you will not be drawing direction fields or slope fields by hand because it's really tedious, then what can we make you do? Well, we can make you match differential equations with their appropriate direction field. So let's look at our options here. So we have y prime, this is one differential equation, y prime is equal to x plus y prime is equal to x, and y prime is equal to y. Fascinating. All right, so you can do this a couple different ways. There's a little bit of a logic argument to it. So think about for a particular value. So let's say at 1, 1. So let me just make an example here. If I had the point, so x comma y, if x comma y was 1, 1. If I was in this first differential equation, what would I have? I'd have 1 plus 1, which is 2. Okay, so I would want to go through here and look to the points over 1, up 1, over 1, up 1, and see which one of them I think has a slope of 2 at that spot. So 1, 1, 2. Oh no, they all look like they have positive slope. Bummer. Okay, well that didn't work, so let's pick a different point. How about over 0, up 1? If I have over 0, up 1, then I would have a slope of 1 on that first graph. All right, so let's look here. Over 0, up 1. Okay, over 0, up 1, look at that flat line right there. There's no way this is graph 1. It can't be because it's 0 there. All right, now let's look at graph C, just because I went down to it. Over 0, up 1. Okay, that's got some positive slope. That could be 1. Over 0, up 1. Okay, that could be 1. All right, so that leaves us these two. So now I know A is out. So now I could pick a different point. How about negative 1, 0? Because I noticed negative 1, 0 is flat on this graph. So that would be kind of interesting. So let's look at negative 1, 0. So negative 1, 0 would give us a slope of negative 1. Okay, but again, on this graph, it's not negative 1. It's flat. There's like a little line in there. But over here, negative 1, 0. There you go. So I'm picking some different points and I'm comparing the slopes. So this is graph B, or if you like, this is equation I. All right, let's keep going with that table. We'll keep the points consistent and we'll change the equation. So now we're going to look at number 2. Okay, so number 2 says, a differential equation number 2, says that the derivative, the slope, is equal to x, and just the x value. So that means that the slope is 1, the slope is 0, the slope is negative 1. Okay, so let me go here. So over 1, up 1, oh, I know this one's out. I don't have to even look at this one anymore. So over 1, up 1, slope of 1. Over 1, up 1, slope of 1. That didn't really help. All right, 0, 1. So over 0, up 1, that would be here on the y-axis. I would have a slope of 0. Ha! Look at that. Let's check the other one. Over 0, up 1, not a slope of 0. So there you go. So this one has to be graph A. Has to be. All right, let's do the third one. Now technically, of course, we know it must be C. But of course, it's possible for your instructor to give you more graphs than there are equations, or vice versa. So we would want to be able to make sure that we can verify this. So for this one, it's just equal to the y value. So I would look only to the y value. So it would be 1, 1, and 0. Okay, so let's verify. Oh, I should have done this really quick. This is graph 2. This is graph 1. This one's going to be graph C, but let me verify it. So over 1, up 1, 1 doesn't help us. Over 0, up 1, 1 didn't help us. Over negative 1, up 0, however, right there, it's flat. There's little lines in there. So that's really helpful, right? That can tell us. And then just thinking about it a different way. If you look at this graph, so this is graph C, notice what's happening. So at 0, it's flat. Look right there. At y is equal to, say, a quarter, all those slopes are a quarter. At y is equal to a half, all those slopes are a half. At y is equal to 1, all those slopes are 1. 2, all those slopes are 2. Right? This is the one where it's equal to y, because those slopes are equal to those y values. Similarly, looking at this one, at x equals 1, look straight down. All those 1 values, all those slopes are identical. At x is equal to 0, flat, 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 flat. All those lines are flat. At x equals -1, -1, -1, -1. Right? So that's another way you can visualize it. A lot of times you can do the visuals sometimes for the easy ones, and then you have to kind of use points for the trickier ones. That can sometimes take place.